Okay, Assalamualaikum and hi everyone. So today we're going to continue with our programming on AI using Python. So the first step is for us to fire up our Jupyter Lab. But before that, let's navigate to the folder that I have my Jupyter Lab notebook. Take the copy the address and let's navigate to this folder. And from this folder, we can fire up our Jupyter Lab. Okay. Okay, for today, I have prepared the Python notebook for you. And basically, the outcome of today, we're going to learn on the basic of Numpy, Pandas, and Matplotlib. So these are all the packages that we're going to be used in this course. Basically, Numpy is the Python library for numerical computing. It's similar like MATLAB. Pandas is a Python library for data analysis and manipulation. And lastly, we're going to look at Matplotlib, which is a Python library for creating plot and other type of visualization in Python. So the first step is to install all of these library or packages, as some may call it. So in order to do that, we're going to first navigate to our virtual environment. So whenever you want to install your this whatever Python package that you want to install, we're going to use this pip command. Okay, so navigate to the virtual environment. And for example, if I want to install my numpy package, I'm going to use this command pip install numpy. But in my case, I already installed numpy. This will not be executed because the package is already in my virtual environment. The same goes with pandas. Just copy the command over here and run it. Okay, pip install pandas. Oh, sorry. Pip install pandas. Okay, again, I already installed in my virtual environment. So the command will not be executed, but if you don't have pandas in your virtual environment, this command will actually install the package inside your virtual environment. And you need to do this for all of the three packages listed here because all of these three packages we'll be using in our course. Okay, once you have installed all of these packages, the way for us to import these packages on top of our Python notebook is by using this command import numpy, import pandas, and import matplotlib. Basically, is importing the packages into your Python notebook. So if you run this, provided that you have installed the packages previously, you should not have any errors while importing the packages. You can import it like this, but normally using standard convention and best practices in Python, we will import the numpy, pandas, and plotlib as a class. So we are using alias over here. So the name can be anything. You can name it whatever you want, MP or any or whatever. But it's according to convention that for NumPy we use a np to, alias to import the NumPy pages. Similarly for pandas we use the alias pd to import the packages, and matplotlib we're going to use only certain features of the matplotlib, which is pyplot, and we import it as plt. So okay, once there is you have verified that the importing is correct, let's look at on how we're going to use NumPy. So basically NumPy you can view it as the MATLAB arrays. Using Numpy arrays allow for easy computation of the vector multiplication, addition, and other matrix vector numerical computation. To create a Numpy array, we will need to create a list. So this list over here is a list of numbers. So we're going to create a list first. In this case, I will create a list of array A. Next, we're going to convert the list into the NumPy array. So there's actually a lot of ways on how you're going to create an array, but this is one way on how you're going to create a NumPy array. So if you run this code over here, we will see that we have two array A and array B. Both will be converted using the np array method, and we will print the array accordingly. So NumPy array, as mentioned previously, allows for easy numerical computation like vector multiplication, addition, and so on. So in this case, over here, I'm just demonstrating a multiplication of an array with a scalar 2. So 2 multiply with array A. Over here, we have array A of 2, 3, 4, 6. Basically, we multiply it with a constant. We have 4, 6, 8, and 12. So this is the output. And this is another example of array to array addition. So if we add the array 2 together, we will have this result. So remember back in our last course, the plus here, if this is not converted into a NumPy array, both of these lists will be concatenated. So in order for us to perform MATLAB style computation, we have to use NumPy array. So that is on NumPy. Okay, next we're going to look at on Pandas. So Pandas is an open source Python package which is used for data science and data analysis and also machine learning tasks. It is built on top of NumPy, which support multi-dimensional arrays. In this course, we'll be using Pandas to actually import data and perform some basic data manipulation and analysis. So in Pandas, there's a concept of series in which you create a series, Pandas series from a list. So this is just example of how to create the Pandas series from a list. So unlike your NumPy array, your list can be anything. Your list can be a list of numbers, a list of words, characters, just about anything to create the Pandas series. So a series is just a precursor towards data frame. So next we're going to look at on data frame. So basically data frame is just like you can view it as like an Excel spreadsheet in which we have the first column as the index, and then the later column contains the data, and on top of the later columns you can see there's a header A, B, C, and D in this case, like the output of cell number 7 shown here. So this is just to show you the what a data frame looks like. So in this case, I created just uh, the first column to be a period of date, not a period of date, just a bunch of dates starting from 1st January 2013 up to 6th January 2013 using the data range method. So this is this data range method is actually a part of function and methods that you can call when you are using the pandas. Okay, because we have imported pandas as pd over here, so we can call the method using this dot notation here, pd dot dot data range. So this data range over here is just a method made available to you by the Pandas packages. So there's a lot of methods available in these packages. This is just to show an example to you and how I create the first column with a bunch of numbers. Next, to create a data frame, we use this dot data frame method, like what's shown over here. In this case, the first column, the index of the data frame, is being fed with the variable dates just now. They have created this pd.data.range over here. And the next columns A, B, C, and D is just a bunch of random number. So I'm using a Numpy method, np.random.rn over here, which created a 6x4 matrix, a random 6x4 matrix. As you can see over here, if you count this up, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So these columns A, B, C, and D is just a random matrix. And then we're going to we're going to name each of the columns with appropriate header, whatever you want. So in this case, it's just an example, A, B, C, and D. So when I execute this command, I will get this output. So this is just to show you what a data frames look like. In Pandas, we're going to use a lot on data frame, and there's a lot of way on how you're going to access the columns, the particular data. Like if you want to access whatever in column here, you're going to use this type of command. Okay, remember back that our data frame is assigned to this df variable. So I want to access the column A, so I'm going to use this kind of notation. So df square bracket A, this will list out all of the values in column A. And you can also like using the Python slice method. Okay, so in this case, if I want to extract only the first 3 rows of this data frame using the index over here, so I can use this double dot notation to highlight where should I start and where should I finish slicing the data frame. So in this case, I'm going to start with 0201300101, which indicate the January 1st, 2013, starting from here up to the 3rd January 2013. So when I execute this command, it will give up a data frame that has been sliced from the position that we have set. Next, we can use the log method, the f.log method.loc method, to just extract one data point from the data frame. So in this case, for example, I want to extract the data at 2013 0101 and at the column A. So it will extract this part of the data. So if you run this code, you get this kind of output. And the thing that I want to highlight here is that using Pandas, you can easily read data from a file. So in this case, I want to read data from the data.csv file. So if you see in my folder, there is this data.csv file, which contains a bunch of data. Like first column is the duration, second column is pulse, max pulse, and calories. This is just a bunch of data I've downloaded from the internet. which I think shows the amount of calories burned based on the duration of exercise, and also the rate, the heart, I mean the heart rate, okay, the pulse, and the maximum pulse of the heart rate. So we want to import this data from the CSV file into our Python notebook. So how we're going to do that is we're going to use this pd.readcsv method. Okay, so you're going to supply the name of the file inside this method, and what this does is that it will convert all of the data from the file into this variable in the form of a data frame. So when you have all of this data inside the data frame, you can easily do anything with it. You can plot it, you can do slicing with it, analysis with it, anything that you want. So another thing I want to highlight over here, this data.csv can also be viewed in your Excel. So you can imagine that if you have a bunch of data you want to put in Python, you can record it using this .csv format, and then you can easily import it in Python using the mentioned .readcsv method. Okay, and the last thing I want to highlight for this part is that in Pandas there's a method on which you can convert the data frame onto your Numpy array. So in order to do that, we're going to use this toNumpy method. Okay, so by using this method, this is the name of the data frame that you want to convert the data into your Numpy array, and this is the method. So if you do this, what it does is that, so you have this duration column over here. So supply it with a duration. This will convert this column into your standard Numpy array. So now this duration variable over here is not your data frame, but it's actually a Numpy array. So now it is converted into Numpy array. And both of the Numpy and Pandas topic are actually a bit huge to be covered over here. So I encourage you to look at the documentation of both of these packages. So in Numpy, you can browse here what Numpy does, how to use Numpy and everything. Basically, this lists all of the information that you can find about Numpy. Similarly, I have post the link towards your Pandas basic on using Pandas package in the notebook as well. So you can look at this website on how to use your Pandas. Okay, so that's all about Numpy and Pandas. Okay, the last part we're going to look at is on the use of Matplotlib. So basically Matplotlib is a package or you can view it as a library for 2D plotting in Python, and it produces high publication level quality figures, and normally it is used for plotting, visualization, and analysis of data. And among the types of plot that can be produced using Matplotlib is histogram, uh, your normal plot, power spectra, bar charts, error charts, scatter plots, and there's a lot of plotting you can use with Matplotlib. So in this example, the first example I want to show you is how to create a linear plot of between the value of 0 to 100 versus 0 to 10. So in this case, I will first create a NumPy array. So remember back NumPy array. you supply it with list. So I make a mistake over here, 0 to 10 to 0 to 100. Okay. So first I'm going to create a list, and this will be assigned to X points and Y points. Then you can call the plot function, because just now, if you remember back, we have imported the matplotlib, the plotting functions of matplotlib as plt. So you can call this function plot from, like, using this notation, plt.plot, and supply it with the data points according to the x-axis and according to the y-axis. So if we execute this command, we will have plotting. This is just a linear plot to show you how you're going to use matplotlib to plot your 2D plotting. Okay, next, this is the second example on how you're going to create a plot of y equal to x squared. So just now, if you see, I'm using the .array function or .array method to create just a bunch of lists. But here, I just want to show you there's another method uh, you can create data points for the x-axis, which you're going to use this linspace function from Numpy, np.linspace. So basically what this does is we will create a bunch of data, a bunch of numbers in the form of NumPy array, starting from -5 up to 5 with 100 points in between. So if I execute this, and let me just check what is X point, you can see that X points will contain a bunch of data from -5 to 5 with a total number of 100 points between it. And you can just use the X-point.shape function to show you the amount of numbers that this array contains, these X points contain. So, and then I'm going to create a second array because we are plotting y equal to x squared. So y is the square of x point. So in Python, remember back, you can use this operator to create a square. So when you do this, all of the data inside your x points over here will be squared, and this will be assigned to the y points variable. So basically now your y points will contain all of the x points squared. Okay. So, and then once you have the data for your x-axis and the data for your y-axis, we're going to again run this function plt.plot, supply it with your data from the x-axis and supply with data from your y-axis, run it, and then you'll get this kind of plot. But if you can see, well, like shown over here, you see this is not a very beautiful plot, but in Matplotlib, similar to MATLAB, we can create a much more beautiful plot. So like in this example over here, I'll create a plot of y equal x squared, supply it with the label, the title and the label. So I make a mistake over here. This should be x, this should be y. Okay. And then draw a grid on top of the plot. And they're just basically to show you that you can make it nicer using certain functions from Matplotlib, like set the X label, set the Y label, set the title, add the grid, and set the ticks position, meaning you want to set all of these ticks over here. And then this will be, you can assign it with certain parameters like what color do you want, okay? and what line style you want for for example, in my grid, what line style do I want, the width of the line and everything. Basically, this is just like a MATLAB plot where you can supply parameters and supplies certain uh, color or whatever to the plot. Okay, so again, similar to your Pandas and Numpy, this package, the functionality of this package is quite huge to be covered in this short video, but I encourage you to look at this link that I have given you. So this will show you all of the functionalities of Matplotlib. Basically, you can make any kind of plot using Matplotlib in this website, shown in this website. So if you have time, just go through this website and see all the types of plot you can do using Matplotlib. So that's all from me. Okay, till next time. Bye.